Hello there. Welcome to this session where we are talking about database management systems. We'll start by doing a recap of the areas or the issues that we have touched on so that we ensure that we are on the same page as we move forward. So some of the things that I've asked you to go and look at and research further on that we have talked about include having an overview and an appreciation of what databases are, having an understanding of what is a database management system, what are the types of database management systems that are available at our disposal that we as informaticians can use. However, of interest to us in this instance that we are going to focus mainly on relational database systems. We also talked about the various models that are there as well. We talked about I think on this one, I asked you to go and look at it in detail, the various components that make up a DBMS. Then we also looked at the benefits and advantages of using a database management system in comparison to the traditional way of doing and storing files. So I think in our previous interaction, we also defined these are the building blocks of your SQL databases or of your relational databases, where we defined what data is, what is a record or a tuple, what is a field, and ultimately that which builds to a database. So by now I expect you to have an understanding and appreciation of these terms as you will be creating and defining these items in your database. So this is the first table that we created, and I asked you to populate some data on this table as well. Then we upgraded it to something like this. Hopefully you saved that exercise and you have it for reference purposes. So today we want to break down the various components of our SQL language that we are going to be using or that we are using in this course. When you look at SQL as a language, it's divided into about 4 or 5 categories, which is data definition language, data manipulation language, data query language, transaction control language. So these 4 components are what make up your SQL language that you use in what? In managing, in creating, and manipulating your database. So we have DDL, DML, DCL, and TCL. So data definition language is what is used to create and modify your database. These are the commands that you require to create your database. These are the commands that you require to create your tables. So the main commands that make up data definition commands or the data definition language are: one, the create command, which is used to create new objects in your database, which is used to create new databases. The outer command, which you can use to modify your databases, which you can use to modify your tables, which you can use to modify any other components in your database. The drop command, which is used to delete objects in your database, be it a table, be it the database itself, be it any other part of your objects that make up your database that you want to delete, you use what? The drop command. The truncate command, which is used to eliminate or to delete records from a table, and the rename command, which is used to rename objects in a what? In a database. So for example, we will try to run some of these commands so that we see how they operate. I am sure by now we all have used MySQL that is operational and running. So let me just open my SQL Workbench command line. I know in our instance we are supposed to be using MySQL on a Linux machine, and in our first practical session we went through the process of running MySQL from what? From the WSL terminal, and we are using the Ubuntu variant of our Linux terminal or our WSL. So for instance, we said the data definition language, we have the first command, which is the create command. And for you to create your database, let's say we want to create a database called medical informatics and analytics, we'll use the command create database medical informatics and analytics. Then we'll run what? The command. Remember, I said all SQL commands are terminated by a semicolon. And when you've run this command, you can check and confirm if the database has been created by running the command. Let me try to increase. Let me see if I can be able to bring this part. All right, something like this. All right. So we say show databases, and let's see if we have created the database successfully. So if I run this command, this is the list of what? Just turned into a full screen. Let me try to minimize it and move it a little bit like this. Try to adjust the size. Right, so this is the database that we created by running the command, by running this command, create database. So it means our database was successfully created. Using what? The data definition language command create. So we can also create our second database so that we get to execute maybe another command like the drop command. So let's say we want to create a database, a second database. I'll just use and maybe call it medical informatics and analytics 2. Then I run the command. And if I'm going to run the show database command again, we can see I now have what? The medical informatics and analytics 2. So which means I've created 2 databases there. If I want to delete that database, I'll say drop database. So I'll say drop. I'll use the command drop database medical informatics and analytics and run the command. And if I run the command show database, you can see the. So if I run this command drop database, it will delete my first database that I created, which was medical informatics and analytics. Then I will remain with medical informatics and analytics. And if I'm going to run the command to drop again, I want to drop the second one. And if I run show again, as you can see, both databases are now what? Are now gone. So this is how you use what? Your data definition commands to create databases in your what? In your SQL. So when you're creating databases and deleting database in your SQL Server, use the create and the drop command. Let's go ahead and recreate our databases so that we can create tables inside them. So I'll recreate the medical informatics and analytics table. All right, let's create. Let me recreate it. Where is that command? Right, I've recreated it. So let's see if it's now existing. Show databases. Yes. So this is the tab, the database I've recreated, and we want to create a table inside that database. So let's create a patients table inside that database. We do so by using the command create again. In this instance, we are now specifying that we are creating a table. For the database, this was just create database. Now for the table, it will be create table. Then we specify the columns that we want to make up that table. So in this instance, I would like my table to have these columns. So let me just paste the columns that I want the table to have. I want let me paste it in or let me open a notepad here. All right, something like this. Then these are the fields that I want the table to have. I want to have a patient ID, which will be more like my primary key. It will be a unique column. We know that first names can be similar for a number of people, so does the name. So if we create a unique identifier, which means the contents of this column won't be empty. The patient ID will be unique for each patient. So these are the the columns that I want my table to have. So the command for creating it would be what? Create table patients, like this. Then we specify the columns that are there. Previously, I think in our first lesson or when we did our practicals, we were not specifying the data types, if I remember very well. There's something that we were not specifying, but in this case, we want to specify the data types and also specify that the contents of the various fields or the various columns there should not be empty. So this is how we do it. Usually I want to terminate because sometimes you end up forgetting putting the semicolon. So we want to have the patient ID. Then we also want to have the first name, let me do this. I bring them here like this, then I copy them at once like this. So this is how you create your table, something like this. Then you go on to specify the data types for each of these items. So in this case, maybe for first name, it will be of the type varchar. I know I asked you to read about data types. The last name will be varchar again. Then date of birth will be of the data type date. Gender, we want to choose between two options, male and female, so we will be of the enum type. Then phone number, again, it will be what? Varchar. This one cannot be as long as the name, so we can put, let's say, 15 characters here. So we say the patient ID has to be unique. So in this case, we'll make our patient ID the primary key, and it will also be on auto increment, something like this. Patient ID is it's an integer, then it becomes our primary key that is on auto increment. So after I've created my table, let's go and run the command in your MySQL terminal and see if we can have that table, something like this. I'll paste what I right. Oh, we are supposed to say use before we run that command. We want to use the database, medical informatics and analytics. Use database. Use medical. Just copy this. Use medical. Paste it. I have changed the database. Then when we've changed, we then run this command again to create the table. So you first create a database, then you select the database you want to use using the command use what database. So you use the database informatics analysis, then we create the table like this. So our table has been created. Let's try to view the contents of our table and see what is there in this table that we've created. And if you try to view the contents, it will tell you that let's move it like this. Select all from table. So it's telling me that my table is what is empty. So let's try to populate the table a little bit. We'll just try to add one or two records there and then run again the command to view everything in the table. So we want to insert two records into the table. So this is the command that we will use. Insert into patients table. We want to insert the first name, the last name, the date of birth, the gender, and the values are, for the first name it's Bote, for the last name it's Dope, then the date of birth then the gender, then the phone number. The second record that we want to insert is the one for Linda. Then we run the command and let's see the result. So after running our command, let's try to select everything that is in the table. So we'll get a result like this. If you are to select everything that is in the table, so this is how you populate or you add records into your database. You use the command. Let me try to open this notepad so that let's try to add more records into our database so that we have 5 or more records. So I'll just run my commands again to add a few more records so that currently we have two records in this table, in the patients table. So we want to add more records into that table. So we'll run the command insert into patients, then we insert the various records that we want to add there. So it's saying I've added 6 more rows. So let's see if that is changing anything if we select again. So that's how you use the insert command to add more records into your table. So that is the manipulation or the updating of or the adding of data into a table in a database that you have created. That is the patients database. So that is the patients table in the informatics database. So as a recap, the commands that we have used while looking at data definition, these are the commands that we have used. Let me just bring them here. Create database medical students for creating the database. Use medical informatics for us to be able to start using the database. Then we also use the create table patients to create the table. Then you specify the columns for the table inside the bracket. Then we went on to use the command to insert contents into the table. In this case, we use the insert into. So it was insert into patients. Then we specify the values, something like this. Not this. Insert into patients. Then here you put the column details, columns. So that was the column first name, last name, date of birth, blah blah blah, until the last column. Then you go on to specify the values. Then you terminate your command. So these are the commands that we have used so far. So this is what data definition language for you. So I want you to alter the table that we have created there and add another row, sorry, another column to that table. So currently our table has these columns. Let me try to bring them here. These are the columns that are on our table. We have first name, last name. So these are the columns that were on our table. I want you to add another column, maybe let's say address, to your table. I would like to see how you are going to do that. So that one, you do it, then you send me the results for that. So let me go through the other commands that you will find in your SQL. So we have talked about the data definition. Then we also have commands that are categorized as data manipulation language. And I think under data manipulation language, we've already used the insert command to create and insert records into a database. So we'll come back and demonstrate how we also use data manipulation language. So commands under the data manipulation language, we have the insert command, the update command, the delete command, and we have also the select command that is used to retrieve specified records. So the primary purpose of data manipulation is to allow the user to interact with the contents of the database, by adding, modifying, or deleting records. So what you're basically doing with the data manipulation commands is you are able to play around with the contents of your database, to change them, to move them around using what are called data manipulation commands. Then we have what is called the data control language or data control commands. These are used to determine the kind of access or the kind of rights or the kind of actions or the kind of privileges that a user is allowed to do or is allowed to perform on a database. Some might be you are only allowed to view, you're not allowed to change anything. So as part of your security mechanism on your database, you define user privileges. What can a user view on a database? What can a user do on a database? A very good example is your student management system that is used to manage your results. The only privilege that you have on your email as a user or as a database user is to view your results. You can't alter or insert anything on your results because you don't have those privileges. So the database administrator is the one who is responsible for granting these privileges, that as a student you can update the table related to your personal details only. You can't update the table related to your marks, to your coursework. So the database administrator then defines and assigns these rights. So the commands are primarily concerned with user permissions and privileges. So this ensures that there is stability in the data there's consistency in the data, is only specified users are allowed to update certain sections of what? Of the database. Then we have what are called transaction control commands. So when you are using your database, you should be able, or let me put it as the feature that you see in your word, the undo command. There are some things that you might do on your database, then you realize that you have made a mistake and want to move back to the previously non-working configuration. So with the rollback command, which is used to undo changes that would have been made on a particular transaction, or to go back to a set restore point, the last non-working functional configuration, you roll back to what? To that point. So this is very important when your user has made some errors. You want to revert back or to roll back to a point where you knew everything was working well. Then the other command is save point. We have worked very well and you think everything is correct, or have confirmed that everything is correct. You use what is called the save point. This allows you to create a named point within a transaction or within your operations, which you can safely roll back to later if mistakes are discovered, or if you think there are issues that have arisen during your working. So as a user, you should be able to define, when you see your data, that this is a save point. I think everything here has been done correctly. Let me save it and mark it. When I'm working going forward, if I make any mistake, I should be able to come back and start from here to going forward. Then we have what is called the transaction control language, or the transaction control commands. Transaction control commands are there to ensure that transactions or actions that are executed by a user when you are managing or when you are working on your database, they are executed in a consistent way that maintains the integrity of the data in the database. So they are very important when you are dealing with data manipulation language, when you are dealing with statements like insert, update, and delete. But they ensure that when you are saving something, it's saved completely or it's not saved at all. So what they control or what they operate with is what is called the ACID properties. So the ACID properties, they talk about atomicity, consistency, isolation, and durability. So when we talk about atomicity, it means when you are running a transaction, it's either the whole transaction is done successfully or none of it is done at all. So which means, let's say you are saving I'm capturing your marks as a student for maybe for your coursework. I've captured maybe your assignment 1, your assignment 2, your assignment 3, then your assignment 4. And all this is supposed to be average to what? To bring me your coursework. We cannot have a situation where I captured 2 marks and when I try to compute your coursework, it's computed with 2 marks while the other 2 have not been what? Have not been captured and computed. So if it's calculated with 2 marks, it means we are going to get a wrong mark, yet it's supposed to use 4 marks. So this rule says that all things in a transaction must be completed successfully, or none should be done at all. Then the other issue is the issue of consistency. That is very critical and that is very important when you are dealing with data. You want the contents of your database to be reliable. You don't want the contents to be changing unnecessarily or unknowingly, or to have changes where you can't really explain what is really going on in your database. Then on isolation, all transactions must be executed independently without affecting any other transactions. So a transaction must be executed independently and completely. Like I was saying, when we are executing I was giving an example where I have 4 marks for a coursework that I'm supposed to capture. Then when processing or when executing that transaction, it only uses 2 marks out of the 4, and which end up giving you a wrong result. So that is not acceptable, and that should not happen when you're processing your data or when you're capturing data in your database. So when we mean it should be executed in isolation, it means when I'm computing your 4 coursework marks, the fact that the next transaction for the next student has 3 coursework marks should not determine or should not affect the processing of your transaction. Then the other thing is what durability. Once a transaction is committed, its changes are permanent and must survive system failures. I know I was giving an example one other time where I was saying you might have an examination system that displays your results as having passed. Then the next time when the database is refreshed, you are getting a different result. Which means the durability is not there, the consistency is not there. So once a transaction or once your coursework for the 4 marks has been computed and has been displayed, those changes should be what? Should be permanent in the database. Then we have what are called what is called the DQL, data query language or data query commands. They allow you to select and view specified items in the database. In the commands that you use, we have the command select, from, where, group by. These are used for querying your database. These are the other commands under the query language, having ordered by, limit. So we will also experiment with them. And the main purpose of the data query language is what? To retrieve specific data from a database, to filter data in a database based on a specified criteria. You should be able also to summarize the contents of your database. You should be able to summarize various aspects or various information that you want to visualize in your database. You should be able to merge and separate different data sets and present it in your preferred way or order. SQL constraints. These are rules that are informed or that are enforced on data. For example, in the example that we used when we were defining our SDF command, where is that? Where we're saying, let's see if I can be able to bring it. I don't know, let me bring it like this. Let's delete this and try to find command where we use the constraint. So this is the command where we use a constraint, and in this case we specified that, for example, the first name we say the first name was not, the column for the first name was not supposed to contain a new character. That's a SQL constraint. So constraints could be at a column level or at a table level. They are used to limit the type of data that can go into a table, or to specify what exactly is supposed to be to be captured in a table. If your constraints are specified clearly, it means if you say this column is for integers or it's for numbers, only numbers will be accepted and nothing else. If you say this is to offer numeric text, and if someone enters numbers only, it means that entry will not be accepted. So these are some of the constraints that are available in SQL. Not new, which is what we used here, which means we are not accepting empty values in our database. Primary key, I think we have used this one as well. We used it in defining the patient ID as the primary key, which means it has to be unique. So we'll be using this as we are going forward. So let's go back to our SQL command line and then try to use some of these commands so that when you are now using them, you know what is happening. And I think we had already used the insert. Now you know when you see the insert command, where exactly does it fall in your SQL commands? Is it a data definition? Is it a data manipulation? So let's try to use some of these commands. We had said we had added records into this table. So let's see what we can do with this table. I think it has over 8 records. So let's try to manipulate this table using a data manipulation command that can allow us to view the number of females in this table. Let's run the command. We want to select all females in this table. So we want to select from the patients table where gender is female. It's saying what? Column doesn't match value of column 1 it counted. So if I run the command again, select all from patients. No, I've just rerun this command here. It had given me an error. And I've just rerun it and it's given me a result. So I don't know what had I done there wrongly. So I'd say select all from patients where gender is female. And this is what I get. So from the patients table, this is where what? All those who are of the female gender. Let's try to run another command. So let's just go back to our slide and see which of those command divisions have we used. Here's our slide. Select all from data query language. So we have said select all from the patients table. So which means on our data query we have used what? 3 commands here. We have used select, we have used the from, and we have used the where. So we will select all from where gender. So that's data query that we have a data query that we have done. Let's try to run another query where maybe we are looking for people whose date of birth is greater than 1 January 1980, and let's see what we'll get. If we run the command select first name, last name, and date of birth from the patient's table, where the date of birth is greater than what? 1980. So if we run this command, select first name, last name, date of birth from patient where the date of birth is greater than 1980. This is what we get from our table. So these are just examples of how you can query your database using data query commands. So let me end here. I want you to run this command and experiment and see what you get or display. Pause whenever you want to pause and redo it and see if you get the same results. Thank you very much for your time.